Hello, everyone. My name is Jamie Willett. I'm a consultant at Encryption Consulting. Encryption Consulting covers all aspects of the data protection landscape, such as encryption, data security, key management, and privacy. We help clients in understanding and implementing cybersecurity models as per their individual threat landscapes. After a brief introduction, we will discuss and define Zero Trust. We will explore how you can secure Kubernetes clusters using Zero Trust principles. And we will examine Zero Trust best practices for Kubernetes clusters. As businesses continue to adopt cloud-native technologies, Kubernetes has emerged as a popular container orchestration platform. However, securing Kubernetes clusters can be challenging, and traditional perimeter-based security approaches are no longer sufficient. This is where Zero Trust comes into the picture. In this video, we will explore how Zero Trust can help you secure your Kubernetes clusters. Zero Trust is a security concept that assumes that no device or user should be trusted by default regardless of their location, and that access should only be granted after successful authentication and authorization. This means that every request is treated as a potential threat and is scrutinized before access is granted. Zero Trust is not a technology, but rather a security model that involves multiple technologies and processes working together to secure networks, applications, and data. Kubernetes clusters consist of multiple components, including the Kubernetes API server, etcd, and worker nodes. To secure a Kubernetes cluster, all of these components must be protected. Here are some ways that Zero Trust can help secure Kubernetes clusters. Network segmentation. By segmenting your network and isolating your Kubernetes cluster, you can limit the potential attack surface. This can be achieved by deploying a virtual private network, VPN, firewalls, or software-defined perimeters, SDPs. Identity and Access Management, or IAM. IAM involves the management of user identities, their access privileges, and the authentication and authorization processes. With Zero Trust, IAM is critical, and access to Kubernetes clusters should only be granted after successful authentication and authorization. Multi-factor authentication, or MFA. MFA is a security mechanism that requires users to provide two or more forms of authentication to gain access to a system. With Zero Trust, MFA can be used to provide an additional layer of security for Kubernetes clusters. Encryption. Encryption can help protect data in transit and at rest. With Zero Trust, all data should be encrypted, including traffic between Kubernetes components and traffic to and from end users. Here are some best practices to follow when implementing Zero Trust for Kubernetes clusters. Follow the principle of least privilege. Only grant the minimum access level necessary to complete a task. Implement role-based access control, or RBAC. RBAC provides a way to manage access to Kubernetes resources by assigning roles to users and groups. Regularly audit and monitor Kubernetes components. Regularly reviewing logs and monitoring the Kubernetes API server, etcd, and worker nodes can help detect any unauthorized activity. Securing Kubernetes clusters is critical, and Zero Trust can help. By implementing Zero Trust best practices such as network segmentation, IAM, MFA, and encryption, you can secure your Kubernetes clusters from potential threats. Remember to regularly audit and monitor your Kubernetes components and follow the principle of least privilege to ensure that access is only granted to those who need it. This brings us to the end of today's video. Please consider subscribing so you won't miss our next video on security and cryptography. If your organization is looking for implementation of encryption, please consult info@encryptionconsulting.com for further information. Thank you.